Hi, good afternoon everyone. My name is Chintan Bhatt and I have with me Sarvanan. We are both working in Big Data Practices Center. So today's our topic is about is Hadoop or is cloud a right companion for Hadoop. So in this talk we are going to talk about today two of the most popular technologies of recent era, Hadoop being the large scale data processing infrastructure and cloud, which is known for its agility, elasticity and economies which it provides, right? So here we're just trying to look at the advantages and challenges to evaluate if Hadoop and cloud can work together. So moving on to the agenda, we will start with basics or 101 of Hadoop and cloud, thereby in that highlighting the basic features and most important features of what Hadoop and cloud provides. We'll look at then the challenges that Hadoop deployment or implementation lifecycle provides, and then we see that what are the advantages of when we install Hadoop or when we deploy Hadoop on cloud, the advantages that we get and some of the challenges that may also occur. After that, we'll look at some of the Hadoop based offerings. We'll look at one of the offering in detail, and then we'll look at what are the typical use cases that's possible with Hadoop deployed on cloud. And finally, we will look at the considerations of Hadoop development and our conclusion. So with that, I'll invite Sarvanan to start with the Hadoop and cloud primer. Yeah, over to you.
Means both are good emerging technologies, and as well as both are outperforming and in its own better manner. So distributed, okay. Hadoop does its level best, and it offers a distributed file system, Hadoop distributed file system. With that, it enables distributed storage of files, and as well as for storing and as well as the retrieving mechanisms. Thereby, it enables a way to process data in a distributed fashion. So that's why it offers the computing medium also. Hadoop tries its level best with respect to how best it can leverage the processing medium by involving a data-centric approach rather than process-centric approach. That means as part of triggering a job or something, map tries to run its best level as part of a node where the data resides in a local. So that's the core advantage of a data locality. So commodity hardware wise, Hadoop is not demanding you to go for higher end, larger scale, infrastructure or something. It says that give me any kind of hardware, I can still run the show. Just by moving those set of hardwares in commodity hardwares into a set of clusters, it still adds up the weightage and it can run the show. Parallel processing, it's basically a divide and conquer methodology. A job in turn gets divided into a number of subtasks. All the tasks runs in parallel together to accomplish the thing, and the result set in turn gets merged together to find the final result set. With that horizontal scaling, so we know that the problem of scaling wise, vertical or vertical scalability is not doing anymore good enough. So that's why with respect to the commodity hardware, as per as the need increases or the data volume drastically increases, without worrying enough, we can add a number of commodity hardwares to the cluster, such that without disturbing the infrastructure, we can easily scale out. So touch basing with with cloud perspective, agility, on-demand provisioning, how best it can provision the hardwares on the need. So just in time of availability and time to market, everything deals with agility factors. Infrastructure as a service. With the infrastructure as a service, it gives you the provisioning of hardware mechanism where you can go ahead and deal with your softwares or onboarding your applications, so on. With platform as a service, it gives you a way to develop or do your application development over there. With software as a service, the developed applications it can onboard it and can run it in a greater manner. So diagonal scalability. With that, Hadoop means, as Hadoop says, it's a scale-out architecture or something. Cloud says that it means I'm not rich to anything. I'm still, scale-out and as well as, vertically scale-up. So both the things it offers. So it's a kind of, leveraging mechanism which is the requirement based on what we have to go for. That's what deals with, diagonal scalability. So public means with respect to cloud, the deviation goes for public and as well as private. So with public, more or less, when we are not sure about the demand, upcoming demand, or when we cannot forecast something, we go for a public kind of mode, and as well as whatever infrastructure which is running over there, which can be minimally utilized or kind of based on the need, it can be computed, and based on the thing you can pay for it. Private, cloud-wise, we coin more or less with respect to the scalability perspective. As we deal with, Hadoop is also, scale-out architecture. Private, cloud gives you much more freedom, and it deals with scalability rather than elasticity. So elasticity deals with, as you use, based on, it gets measured. So based on the measuring, it gets paid over there as part of, public-wise, but whereas private deals with pure scalability. So virtualization. Virtualization is the backbone of the cloud computing era. So it's the virtualization which gives you the scalability, on-demand provisioning of the hardware, or proper utilization of the underlying resources. So pay-as-you-go model with all these features, in turn, cloud. That's how cloud shines in the market. Based on the need, whatever you go for, still you can leverage the thing. So once your requirements done, you can demolish the cluster and you can pay for whatever you have used for. So means after touching these unique qualities of Hadoop and as well as cloud, we would like to address some of the challenges of what Hadoop has. So just by having Hadoop on the premises means the bare metal. So infrastructure management is one of the pain point where though we have provisioning that much huge infrastructure or something, maintenance overhead will be there, and as well as the software things and all other things, data center maintenance, and as well as the cooling mechanism, all other infrastructure comes into picture. Configuration and tuning, Hadoop is a kind of distributed computing, as we all aware of, but with respect to the configuration, there is no hard and thumb rule. We can say that this is the configuration which can do for all the use cases. So it varies based on the need. So there are n number of configurations or parameters which can do the needful, but on making ourselves dirty with respect to each and everything, it takes time. So capital expenditure, when we are not sure about the upcoming needs, we cannot plan for such a capital expenditure area, because it involves a huge budgeting over there with respect to data center, and as well as hardware, servers, networking, coolants, many things. So all these things deals with capital expenditure. So agility, just in time or on demand. So on the demand, how best I can provision the underlying hardware. So that's what deals with agility. With comes availability. Hadoop's, though it says it is quite available with respect to a framework perspective, but when you go for hardware or something, hardware is subject to failure. So that how it's not 100% guaranteed. It's quite available. With this, so how best we can have, or we can integrate Hadoop on cloud such that each complements each other. So whatever the features which lag with each other can be complemented by other stuffs. So just by having Hadoop with cloud, these are the things the advantages of which we coin with. So lower operational costs. With that, so what are operations getting involved over there? So all the operation cost, which is going to spend on a bare metal will be drastically reduced. So since cloud claims that just as you use, you pay it. So with that, the operation cost drastically gets reduced based on the usage. So as per the usage, you pay for it. On-demand, faster provisioning. So agility is one of the factor which cloud offers. With that, just in a point of time, the Hadoop cluster can be up and running with respect to the cloud environment. So then and there, your environment will always be ready to work on with. So it's a case of any kind of testing or R&D something kind of thing. We can onboard that thing and we can then and there do it. Higher throughput, yes, Hadoop offers says that give me any huge volume of data sets. I can still crunch it. I can give you then and the result set. But it's not guaranteeing you that I will be able to do it in a finer amount of time for a small unit of piece of work. So it's a kind of huge crawler which can crunch the data and give you the result sets. Efficient resource utilization. So beneath the hardware is what have to be utilized in a proper manner. So with cloud provisioning and other things, the virtualization ensures that proper utilizations of the underlying hardware. So just by onboarding Hadoop on top of cloud environment, it ensures that the best usage of the underlying hardware. Elasticity, agility, and Aspergo. So elasticity is one of the factors which we have discussed upfront. It's a kind of measurable term. So how best enough you have used, for that alone you will be paying for that. Distributed parallel processing, as we have discussed on that, it's a kind of cloud says it gives you the runtime environment to do a parallel processing, but as such cloud it's not giving you the parallelizing application or something. So Hadoop favors cloud just by going for a parallelized kind of algorithms. So we have seen some of the advantages of having onboarding Hadoop on top of cloud environment. With comes there are certain limitations with respect to that. So data locality versus on-demand cloud. So cloud says that however you have used, so that's alone you have to pay for. So once your usage is over, then we can decommission the cluster. But whereas data locality comes into picture of nativity storage. So wherever the data is getting stored over there, the process has to go and run over there. So in order to deal with, once the cluster is done, we are pushing the data into S3 kind of storage in typical Amazon over things. But what if regularly we are spanning the job on a daily basis? In order to do it, then every time you have to import that much huge volume of data from S3 medium into Hadoop environment, the HDFS or something. So once you've done it, then you have to decommissioning the back. So again, the same effort of overhead is you are taking for exporting the equal volume of data again back to the S3. So as it goes, at some other point, just for maintaining the data locality, you in turn do this kind of transfer rate. Means data, huge volume of data is getting transferred to and fro from S3 into the Hadoop cluster. Import and export parallelism. So as we are aware of cloud environment gives you good APIs to import your data and as well as export the data. But as such, things are happening in sequential but not in parallel. So what if while importing or something breaks out? Again, you will end up in redoing all same set of efforts right from scratch. You have to import all set of data together. So there is no much provision over there to control the need. So apart from that, when you deal with complex set of applications, complex algorithms, when you onboard into a cloud, so they claim that applications which are subject to high latencies, they suffer a huge pain or a huge overhead in just by onboarding into the cloud kind of environments. Because basically, when we say applications which are subject to latency, means latency wise, turnaround time is getting increased, I/O secret is getting increased. But whereas with respect to the cloud, there is no guarantee that whether the data, the underlying hardware, means the hard disk remains as part of the same machine, or in turn we are going for a SAN-based thing or NFS kind of stuffs. So over this, data input-output mechanism rate is drastically getting increased, and as well as with respect to the virtualized bare metal sector-wise, researchers have done an extensive research, and they have claimed that 40% of degradations will be there when you do an extensive set of research by having a cloud on premises, that on a bare metal, and as well as equal set of hardware provisioning for a private cloud kind of thing. So when we run similar set of algorithms on both the ends, they have identified 40% of degradation or 40% of overhead is there, which when you go for a VM kind of things. So basically the hypervisor involves more I/O operations, kind of context switching is getting involved. So there is no guaranteed data locality is getting preserved over there. So with data locality, network overhead is getting increased drastically. So yes, with this I would like to call Chintan on stage. Yes.
Okay, yeah, thanks, Ronan. So, whatever we have covered so far says about what are the features of cloud, what are the features of Hadoop, where Hadoop lags, and what are the challenges, and where combination of Hadoop and cloud can give a better solution in terms of agility, on-demand provisioning, on-demand scaling. Now, with all these aspects, we try to explore some of the offerings that is currently in market available, which provides Hadoop and clouds, right? So as we all know, here we are just highlighting all these vendors of Hadoop, vendors of cloud, and some of the offerings that have come out of their partnership. So as we know, the initial one which started was from Amazon, that was Elastic MapReduce, where it gives you basically a service to process large amount of data, which uses Hadoop internally, where a user needs to upload the data on cloud, and then they can provide various applications like MapReduce, Pig, or Hive to process the data. And Amazon has also now started with, they are also providing the same EMR, which is backed by MapR distribution as well. The other one similar offering which is provided is from Microsoft, that is HD Insight, which is Hadoop as a service on MS Azure, right, which will be very good fit when you have a Microsoft ecosystem and you need to integrate Hadoops with those type of applications. Similarly, there are also some other vendors, some of similar offerings from other vendors as well. One of the project that we just like to explain in detail is the project Sahara, which is in open source community on OpenStack platform. So let's just try to look at it. Okay. So project Sahara, which was previously known as project Savannah, was a joint effort between Rackspace, Hortonworks, and Mirantis. The basic aim for the end user to quickly and easily provision Hadoop cluster and manage it. So what it gives is, it gives you a REST API for an end user, which needs to provide, the user needs to provide the parameters like number of users, number of nodes, and the Hadoop version, the Hadoop distribution, and it can quickly provision a cluster for you. It also provides integration with Hadoop management tools like Apache Ambari, so that plugin is available using which you can manage the entire cluster using Apache Ambari. The other point is regarding configuration. Now, the project Sahara can deploy multiple distributions of Hadoop, and with this Hadoop configuration templates, a user can set a cluster-wide configuration, which can then be deployed multiple times, right? Which makes it easy to configure on the scale. Now, what are the typical use cases that this Sahara project tries to aim? So, the first one being, again, there is a lot of applications happening on Hadoop or big data that requires proof of concept implementation. So one of the primary use cases of provisioning cluster for POC that can be done very quickly, and it can result in quick turnaround time. And then also for dev and QA. So after that use case, the dev and QA phase is over, that can be the resources can be quickly freed. The other use case is of ad hoc query and kind of bursty analytical workloads, right? So this is kind of a data processing where a user just provides a data and the processing that needs to be done on that data. Then the job life cycle and cluster provisioning and all those of stuff is insulated from the end user, where once you submit this, the Sahara project, the Sahara takes care of creating, provisioning a Hadoop cluster based on the requirement of the data, then configuring a job, running it, getting the result, and then tearing the cluster down. Okay. And the third one would be it gives an ability. The Project Sahara gives you an ability to utilize your own OpenStack infrastructure as a service with Hadoop processing as well. So this is just a high-level architecture of Project Sahara. So what an end user can use it. So this shows that Sahara is one of the native component of OpenStack, where a user can either use a horizon component, which is a user interface to manage and create and manage cluster, which in turn uses a REST API provided by Sahara, or user can directly communicate with Project Sahara with its REST API. It also utilizes the keystone component of OpenStack, which is used for authentication, and the user when submits a request to provision a cluster, the user is authenticated by the keystone component, and then it is allowed to act with an OpenStack this thing. Then the Nova, which is a computing framework, a computing fabric of OpenStack that is used to create a virtual machine. The pre-configured operating system and Hadoop, those images are stored in Glance, so that whenever there is a need of a node startup, that can be quickly done. Okay, so those images are stored in Glance, and then for those analytical workload applications where the cluster is only required for the amount of processing to be done, this can make use of the Swift storage services provided by OpenStack. So it can actually act as a persistent file system where your input data which will be processed can be on Swift, right? Once you launch a cluster, your data can be then moved to the HDFS which is provisioned, process it, and the output can again be stored to Swift for a persistence, right? Okay, so now looking at Hadoop's Hadoop and Cloud's advantages and all, which are the typical use cases which are good fit for Hadoop and Cloud. So the first one being an online analytics, right, where what you actually have is when you want to provide analytics as a service, where some of the use cases of kind of customer analytics or churn prediction, they are already implemented, okay, but for that the data is not coming continuously. You want to do that on demand. So those services can consume it. So the user can provide the data, right? It can be then uploaded to a cloud or whatever interface that it is provided with. Based on the size of the data and the complexity of computation, your the number of nodes and the configurations can be configured based on the demand, right? Then the analytic process can be run, get the results, and then the cluster is freed. Okay, so these are the typical use cases where it can be used. The other use case is again which we already previously mentioned, which Sahara is aiming is about provisioning quick cluster for dev QA or POC requirements. The other use cases, whenever some of the use cases where Hadoop is not processing their job in kind of near real time. Your job is frequently jobs which is running either nightly, weekly, or monthly, where between your execution of the job, your resources are underutilized. It's not utilized at all, right? On those type of scenarios, this type of workloads, right? It is similar to what analytical workload is. You can provision a cluster for launching that, for executing your job, do that, and then tear it down. Then the last point, the one of the other use case where it is good is where your data or application is already installed on cloud, right? It is already deployed on cloud, and the data to be generated is already available in cloud. So in that, it is best to provide your applications or the data computing facility where the data is generated, so that you don't need to migrate your data inside your in-premises, and you process that on cloud itself, right? So these are some of the use cases where Hadoop on cloud makes sense. Now let's just look at some of the considerations where which you can consider where and when you need to install you need to deploy Hadoop on. The first one is capex versus opex, which is generally for any application to be deployed on cloud, whether you want to go with the initial upfront investment or you want to have a zero investment, which is the capex model will be preferred by larger clients, right? And then the opex would be for the startup which they don't have a larger capital to work with. They would preferably go with opex model. The other one is performance versus price to performance, where some of the application which requires strict performance guidelines versus you are worried about the cost that you are paying for achieving that performance. Then the data gravity. Data gravity is an aspect where you need to take into consideration where your data is being generated, whether your data is being generated in cloud or on premises, right? And based on that, where your data processing ecosystem should go. Then the regulatory requirements. It depends on a particular organization where how much strict control they want to have on the data. And the last one is agility. So agility is, it requires for certain applications where you don't need to actually wait for starting with your inception of your application to actually get it deployed, right? So with as we mentioned in Hadoop bare metal, there is a little bit of lag until you provision your hardware, then set it up in the infrastructure, and then configure it, right? So some of the applications where that requires. So with that and our experiences, these are what the decisions that can be taken for each of the considerations. The first one being a performance. So as we know that Hadoop performs best when it has exclusive access of all the hardware, right? So on those scenarios or those conditions, Hadoop on bare metal will make sense, right? So these are the cases where the hardware or all the configurations are tuned for a particular application workload. In those cases, Hadoop on bare metal would work best. Then the data gravity. So if your data is already generated in cloud, like the social media data, if you want to process the social media data or some of the clickstream data which is already available in cloud by some of the providers like Omnichar and all. Those data, if you want to process that, it's best to have your application or your Hadoop to process that on cloud, okay, rather than moving it inside your premises. And then if you already have a large data set inside your premises, you can go with in-premise installation either as a bare metal or on a private cloud where you can have a better utilization of your hardware. Then if you need a strict control over your data, right, and some of our clients also had a strict regulation that the data that is generated in premises cannot leave the premises. If such are the scenarios, then you would again go with in-premise deployment with either bare metal or private cloud. Then again POC, dev or QA environment, then you can either go with a public cloud or a private cloud, and considering the other aspects of it as well, like performance or where the data is being generated. And whenever you have the capex or an opex, based on that you can either make an upfront investment on your infrastructure, and then you can either have it on a bare metal for the applications which require higher performance, and then a private cloud which requires better utilization of the infrastructure. Okay, and if you need an opex, you can go with the public cloud or a hosted Hadoop environment. So considering all these points, right? What we like to conclude is having what are the consideration points that can be taken for making a decision of where Hadoop can be deployed, either on cloud or bare metal. But some of the implementation can also be kind of a hybrid. For example, if you have an application where you want to leverage Hadoop for the data warehousing type of requirements, right? You should better have it in as a bare metal, which may also involve some of the data which is in premise. And then if you you want to augment that with the social media analytics as well. So that being generated in available in internet, you can have that in cloud. Okay, so with that, we just want to conclude the session. So any questions? Yes.
Yeah, so when you talk about performance, right? So in the cloud, what kind of performance compared to the on-premise? What kind of degree do you see?
Yeah, so I think,
Yeah.
yes, Arun, yeah.
So to answer your question, cloud has been built with the concept of virtualization at the back end, so hypervisors and other things. So when we go for something, Hadoop works best or Hadoop outperforms with the concept of data locality. So when we go for certain cloud-based things, there is no guarantee that whether your data sits on the locality, the data locality is getting preserved. First and foremost thing, they clearly mention it as data locality is not getting preserved when you go for such kind of public-based clouds, because in order to effectively use the underlying hardwares, they go for computing as a separate machine set, and as well as storage as part of data as a different set of machine sets. So altogether they miss the factor that data centric is not getting preserved. So again it's a kind of wherever the process runs, again the data has to be pulled across. So the network latency in turn is getting increased. And apart from that, in order to highly utilize the basic underlying medium, context switching will be happening between VMs. So when context switching will be happening, it's a kind of again IO operations hardly comes into picture. So with this the suffering of performance increases.
Yeah.
Yes, please.
So which do you think is the bigger performance degrader? Is it context switching or is it data locality? So I mean, the overhead from virtualization or the lack of data locality, which is bigger?
Okay.
I think it would be the mainly data locality, where whenever Hadoop wants to achieve a performance, right, it expects that your processing node and your computation node, the storage node and the computation nodes are co-located, right, and which may not be the guaranteed one in cloud. Cloud may have your processing nodes and your storage separately, right, or even if you have a virtualized virtualized VMs on the same hardware, right? They may contest for the resources, the IO. Yeah. Yes. Yes, sir.
So make it even more specific, right? Like in Amazon, you have option S3 and EBS, right? In your best practice, what would you recommend your customer?
Okay. As per best practices, we would recommend for mapper kind of things to go ahead with using S3 base instead of S3 based things, because a mapper says that it's a kind of mounting NFS based file system. So basically Hadoop kind of framework, when it spams across, basically I'm not sure about whether it's a problem with the architecture or something. The underlying hardware is not 100% getting utilized. So in case of Hadoop kind of architecture framework, it says that only 80% of compatibility is there, means 80% of only hardware processing speed is getting utilized for the framework. Okay. So with this, when we go for a mapper kind of things, it's purely goes for an NFS based things. It's a native file system, sorry, network file systems, and it's pure POSIX complement. So kind of this mounting happens then and there. So means we would recommend to go and use with mapper kind of cloud based offering. Yes, please.
So comparing to the in-premise cluster, is there any potential limitations, say any Hadoop components you can deploy on your own cluster but you cannot deploy in the cloud due to some storage limitations?
Well, we are just aware about one of the offering of Microsoft HD inside, where the HBase was not recently available. So all the cluster components were available, but HBase was somehow not available, but that is in their roadmap, right? So there can be, again, it could also be because, and that is when you are taking Hadoop as a service, right? You still have an option to take those as an infrastructure as a service and install all your components on that. Okay.
They provide this connector, but they have to work with their own version of Hadoop. And then is it
Sorry, I mean, we don't have experience with Google Compute Cloud or not. But yes, I mean, what we have observed is somehow the Hadoop as a full service on cloud is lacking behind the updated version of Hadoop, which you have all control in premise. That's what we have observed. Yeah. Yes.
Sounds like use cases that have high latency are not a good fit or not good companion in the cloud. For example, I'm thinking of enterprises that you would go and offer them, let's say, big data service, Apple service, and so on and so on. Salesforce.com might be a good proposition, but anything that's operations based might not be a good one based on the things that you just said.
Right, that's correct. That's correct. So again, we are not saying that it's totally Hadoop should be installed on in-premises bare metal or it should be deployed on cloud. But considering the use cases, right? I mean, so if, for example, as I mentioned, if your data is already generated in cloud, right, then having that processing on the cloud where it can have a direct access and you can avoid the data transfer into your in-premises, right? That can give you benefit in that, right? And whenever the agility is required, right, quick provision.
Just put all your data there based on the use case and use that as a data lake or whatever. And then data's all there. You can then start to sort of grow the number of use cases that data set itself could
Right, right. But then the initial data transfer from your in-premise, right, that depends on the size of the data as well, right? If you are generating, terabytes of data, right, then moving that into cloud may incur some overhead. But yes, if you want to push them once and then process it, that's fine.
A lot of times, along with the use case, the SLAs also come into picture on where you put it.
That's
Sometimes,
correct.
For SLAs that are real time,
Mhm.
you can't really move all of the data set into the cloud.
Yeah.
What's the timeline for Sahara? Is it part of ICE health or
Sorry, can you repeat that again?
OpenStack? Which release of OpenStack is Sahara going to be?
Currently, I think it's 0.3, right, and still it's kind of in incubation. Yeah.
Is it on the ICE house or is it on the next one? It's in Havana. It's in Havana. So it's over there.
So
Yes. Thanks all.
yeah, thanks very much. Yes, yeah.